Docker containers, as well as publishing our images, that is the container images to. So the first prerequisite for this hands-on session is that you will have to have Docker desktop installed in the system and WSL2 configured. If you are not able to do so, please consider, please look for demo videos available on the net, how to install Docker desktop and configure WSL2. That is actually not part of today's scope. So let me share my screen. Hope it is visible. So as displayed on my screen, if I go and search, I have Docker desktop installed on my system. So today we will do two practice assignments, which which I shared in our class. So just let me open that. Yes, so here you can see that I have a small instruction sheet, a small assignment, which will be on your desktop right away. So we have two applications. We have two applications. One is a Python application, another is a Node.js application. If we see, here is the Node.js application and here is the Python application. So what we will do, we will have to create the container images for Docker to run them, and then we will have to launch the containers and see that ensure that the app is working. Then we will have to drop all the, that is on step number 3, we will recreate, that is drop and recreate the containers, give them names, that is custom names. Then we will clean up the custom containers. Then we will rebuild the images. Now these images will also have name. And now after that, new containers will be run with the rebuilt images as well as the customized container names, and ensuring that whenever I stop the applications, the containers will be removed automatically when they are stopped. I will add another thing to this one, that to publish the application images. So for this step, for this step, there is a series of steps involved. Likely, I need to create a Docker Hub account, then create a repository, each code base, then publish. This will be the sub steps of step number 7. So let us first start working. First, I will, go and review the applications, whatever that is there. So first, we will go to the node application and see what this node application is intended to do. So let me open this file. We normally use Visual Studio Code. Yes. So what we are seeing is, in this application, we have this application listens to port number 3000. Actually, this is running a very small web server, which will print whenever I enter into this web server. Or whenever I launch this web server, it will not just print hello from the very basic node app. So this will be, check if somebody has signed in. Yes. Okay. So this will be my application for Node.js. First, whenever we are trying to build the container image for a application, so we need to first build a Docker file for it. So we will start by working towards a Docker file. So let us open it. Open the folder. Okay, it is already there. So I will just go backwards, select this folder, click select folder. So I am in the node app. So this is the package.json, which is the configuration file for this application, and this is the node application. So normally, while installing a node.js app, we have to install the node image. Then we have to run npm install, and after that we can run the app. So we will configure the Docker file based on that concept. So our file will be, hold on. It will be Docker file. So whenever we create a Docker file, what we do is we will fetch the Docker file. We will fetch the base image, and if I just go to Docker Hub over here, so if I go to Docker Hub, so this is the repository from which we we search for base images. Maximum base images are available over here. So maximum base images are available over here. Can you just give me a high five if I am audible or not?
Yes.
Okay, thank you. So here we can see that if we search for node in Docker Hub, we are seeing this node over here. Okay, we are seeing this node image over here. So we will bring that node image from node. Then what we will have to do is we will have to assign a work dir. Okay, this working directory is the root directory in the image where this where this application will work. So this is the first. Then we will run npm install. So that is required for running the node node package manager. Then we will do a copy uh, copy the package package.json to the destination folder. Then we will run npm install. Then we will copy the application code, that is everything from source to destination, that is dot to dot. Then we will have to expose the port 3000, because the application will listen to post port 3000, because in the code what we saw that it is listening to port 3000. After that we will what we will do is we will run the code. That is very simple. Actually, what we will run is we will run node, and then we will run server.js. So this is the structure of a standard Docker file. It is a very simple Docker file which lists the steps to install the application in the image. Okay. So what we did, we first selected the base image. Just let me check the spelling over here. Yes, we are correct. So node, small node is the node. Then the work dir is /app. Then copy package.json. Then we will do the npm install. Then we will copy the app, that is the source code, that is server.js to the uh, /app folder. Then we will expose the port 3000. Then we will run this node into server.js. One thing I forgot, I didn't do, that is to run the Docker desktop app. So it is necessary before trying to build a container. Just give me some time. So here it is. It is just starting. It will just take some time. Let me declutter the desktop. For those of you who don't have the Docker engine, okay. So here we see that the Docker desktop is started. Then on the Visual Studio Code, we will just open a terminal window. By default, it will come over here. So to build an image, we will have to type Docker, then build, then dot. Okay, I didn't save the file. Let me check. Okay, I have missed a command over here. It would have been run npm install, and this should have been cmd. Okay, yes. Then we will save it. Then so we can see that image building is done. Now we will have to run this image. We will have to run this image. So I copied the image name, and then the command is docker run minus p, minus p for the port. So we have exposed port 3000, and we will receive that port connection. So there are two parts of this minus p option. That is, first one is the external port, which we will have 3000 over here, and then it is the internal port, that is the 3000 of the app, and then we will give the image name. So as we see that this image has started, and it has locked the terminal. So if I just go ahead and open a new terminal here, if I see docker ps, it will show that this application is running with a container id, that is image id, then entry point, blah 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 blah, and it is listening to port 3000. So if we go to my web browser again, and over here if I type localhost colon 3000, we can see the node app running. So this is our first node app. So we have built a docker file successfully for this one, and we can see that the container here, it is running on port 3000. Okay, so we have built a container, and there is the image. So here we have built an image. I think this one, yes, this is 1 minute ago. So here we have built this image, which is still in use, and it has consumed 912.65 megabytes, and we have a container running on based on those on that image. So here it is, that container. So we can see it from command line as well as the desktop. So now it is the time to build our second application. So we will go open a folder. We will go select the Python app now. And here we can see there is a Python file. It is a code to select. It is a code to it is a code to print something in the screen, and then it will collect the sorry it will prepare the body mass index, BMI. So here again, we will build the Docker file. And now this is a, so now let me shut off the phone. It's disturbing too much. Okay. So here now we are going to build the second assignment, that is the Python code. Okay. So if we go to the assignment, if we go to our assignment, it is saying creating appropriate images for both apps. Okay. So we will have we will now just create the container for the Python file. So we will prepare the Docker file over here. And to prepare the Docker file, we need to search for a base image. So we will go and search here also. The image name is Python. What we will do is we will just change this one. We will name this Python. We will have the dir app that is there. We don't need this package.json because it is not required over here. Now we don't need to run this because this is a Python code. Then we can expose the port. It is 3000. It is also not required. Why should we expose the port for an interactive program? So now we will type Python and this b dot URL. So this would be the Docker file. I am saving it. Now let us go to the terminal window, build a new terminal. Then we will do Docker dot, sorry, so now it is okay. So Python image also done. So now what we will do is we will run the image as usual, and the difference will be we will not have any port over here, and we will run it interactively. So it is -I, then we will have the image. It's this one. Yes. So here it is selecting one. Here it is selecting one. So the code has some bugs. So that is not the issue. What we see that this app is initialized in a proper way. Okay. So this app is initialized in a proper way. So this is how we have, if you come again, we can see that we have built the containers for two Python, that is Python as well as Node.js. We have two images which obviously have no names because we haven't renamed the images yet, and they are runnable. So this is shutting down, and if we go to the command prompt from here, that is from the main console, here we can see docker -a it will show that uh, there were two last two dockers are there, that is Python BMI. This has exited because this is a BMI file and this is the node.js file. That is, one is Python file, one is node.js file. So now the next assignment is that, so appropriate images and containers. So as assignments one and two is done. Now we will have to recreate both the containers and assign names to both containers. So to recreate this, so what we did was to create image, we did docker build command, right? Now to launch a container, what did we do? We used docker run command. Now we will have to recreate both containers. Okay, so we will recreate both containers and assign names to both containers. Now on the very first part, we didn't give a name. So here, when we are looking for containers, so there are two something very cryptic type of names: trusting Heisenberg, mystifying Corey. So this we haven't given. We have only given the command. We haven't passed the name. So now to stop this containers from running, what we have to do is we have to issue docker stop command and then choose this name. The other one is already shut down. We will stop this. So now the assignment is, see, until and unless we stop them, we can't rename them. Now we will recreate the, sorry, we will have to recreate both containers. So what we will do is we will remove the containers first. Okay. So how to remove the containers? The command is, first we will have to list the containers. So the command is docker, see docker ps, it is blank now because docker ps only lists the containers which are there on the memory, which are working. The saved containers will be there on docker ps -a. So if I give, see, all the containers that we have saved are appearing here. So we can go ahead and remove the containers. So the first container name here, although I haven't created this one, but again, for simplicity's sake, I am removing everything. Let us see if this works. Sorry. We have to put docker rm. So feedback came. That means it has worked. Now let us see. There is nothing. So now we will have to create containers with names, or we can do one thing. We can first create a container with the docker run command, and then we can assign a name. So first, to know what are the containers are there, what are the images are there, we have to run this command docker images. So here I can see all the images which are there in my folder or in my registry. So it is the docker registry which I am maintaining on my hard disk. So we can remove we can remove all these images. What is the command? All the images over here, we can remove them using uh, Docker image prune. So because all of the images, none of the images are right now in memory or not being used by the container, I can remove all the images like this. So now let me see. Oh, sorry, it is not working. Then there is a very simple command to run. Like this one. Then it is this one, this one. Sorry. These two are same. Here this is repeating. So I will just so there are repositories in this image. Fine. It is not a problem. Let me see if I have been able to remove all the images which I have created right now. So I have been able to remove. So now what we will do is we will create a named image. So for creating a image, container image with a name, the basic uh, ba- basic functionality, the basic command which is used to create a named image is called tagging. So we will we will just tag images. We will tag images and we will build images. Then we will tag them. We will check two options if they work. So first thing is we will create an image. First one is this time let us start with the Python. So we are creating this image over here. So here we have created the image. If we go and see, so here is the repository tag, nothing. We have only the image ID. So now we will have to rename this. What will be the name? Say, so if we go and see the command prompt right now, it is so here is the image name is by image. The tag will be default latest because we haven't given a tag over here. So this tag part will always be latest, that is by default. So here first image is created, we will go for the second one. So here docker build dot. So here we will use another approach, that is we will build an image and we will tag the name to it. So first the command is -t. I will just test this if it runs. Docker build. Now we will have to keep a node. This is node image. Node actually is big application. So uh, we have built the image over here. If we go and see, if we go and see, so there are two images, Pi image and node image. So the next part of the assignment was to build the container. So we have created the containers. So now there are, sorry, we have created the images. Now we will create the containers. Containers will also have names. So actually we have done this one. That is the 5, because I think this needs to be shoved upwards. It should become step number 3, because step number 3, is running, is building the images first. So it should be step number 3. That is not a problem. We will go, then we will create a container based on these images. And now the funny point here is that previously I used to run, build the images on the folder and then run the container from the folder. But now we will not do that, because we have already built the images. So images are there. Now we will have to initiate the images with the container name. So first we will run docker run will be there, because I am creating a container. So to create a container, the command was what? It was docker run. So after that, we will have to give a port for the node, and uh, nothing for the just the interactive tag to the Python. But here, what we'll have to do is we have to provide a name. That was told that we are now naming our images and naming our containers. So here we are running a container, but we will have to provide, first is interactive, then we will have to provide a name to the container, which first one, because it is interactive, so this is the Python one, pycon. I will give it the name pycon. From images, image. So we can see it is working. So we can see it is working. So now if I go and see docker ps minus a, you can see image is py image. Container ID is something which I can't change, but container name I have given PyCon. So this is there. So the next one would be this one would be the Node.js. So Docker run over here will run with the run with the port, because this is a web server. So the port was 3000 and the name the internal port was 3000. The name would be node container, and here would be node img. It is node, the file is img. So now if I go to the browser, yes, if I go to the browser and type local host colon, so it is running. So we are running the, we are able to run this container. Okay. So to stop the container, we must issue the docker stop command. So that we need another command window. We will show how to have the command windows running without attaching it to the prompt, the console running without attaching it to the prompt. So where here if we go like this docker ps, we can see this node image and node cont is running. So we can issue docker stop to this container to stop it. So the container is stopped right now. If I go to the browser, so it has stopped. Now to start the container, we will have to issue start. So this has now started, and by default this time the container is not attached to a port or a desktop. So here now if I give localhost, see it is returning. It is returning. So we have built everything. We have built everything on the images. We have ran the images. We have started the containers. We have stopped the containers. So up to 5 it is done. That is create images, create container, recreate images with name, recreate containers with name, we have given. Now we will now if I see that, if I just uh, if I go to docker ps, I can see that although I have stopped this oh, I have restarted it. Give it some time, it will finish processing. Now if I give docker ps, nothing will show up, but if I put docker ps minus a, all the containers have shown up. So if I try to build update the code, and then I will have, if I rebuild the image and try to rerun the container, what I will have to do is I will have to assign a separate code. Because if I just let me just try this one. So what I am doing is I am trying to run the container again. Say I have updated the code, I have built the image. So image is new. I am just trying to start another container based on this, based on the new image. Say what I did was, I just updated this thing, node app, then yes, I have updated this. Okay, file, I have saved this. Okay, I have updated this. Now, if I try and go ahead and build node image one, a new image, and now I issue the run command. Say here it is uh, docker slash slash name. I would give another name, or rather say same name. And now I try to run the new node image. See, it is giving errors. So the error is you have to remove that container to able to reuse that name. Okay. So if I again change the name over here, say I put node cont one, but now you see it will have a separate error. Sorry, actually that container was not running. I have stopped it. Just give me a second. Docker stop cont one. Stop this container first one. Okay, stop. Now what I will have to do is I will have to run this one, that is 3000, 3000. I will give the node con and node image. I If I start this node cont and then now try to start this node cont one on the same port, it will not work because sorry, it is not working. It will not work because it has the same port. It is accessing the same port. So to do that, what we need to do is we need to rebuild and stop the containers as well as delete the containers. Otherwise, there will be two conflicting images on the server itself. So what we will try to do is, see, this container stays. This container stays. Uh, if I uh, if I now see, if I want to reuse the container name, I will not be able to. I am just, I am just compelled to use this node cont one and node cont just to, issue a new container or run a new container. So to just to reuse this part, what I will have to do is I will have to automatically remove the containers when they are stopped. That means that every time I stop a container, that container must be removed. That container should not stay in the memory to clean up the containers. Otherwise, what we will have is like this. We have node count, we have node count one, we have PyCount, we have PyCount one. So there are multiple cases that will be happening like that, and those of us who works with containers knows this thing. So the trick over here is, first let me stop these two. Then the node count one and stop. Then what I will do is I will remove the containers, that is rm. We have removed the containers. Now we will start the containers with a condition that they will automatically be deleted whenever they are stopped. So the command is I have this over here. Here, when we are starting a container, just I will also provide -d to start them with detached mode. Uh, Whenever we put the container name, then we will put --rm. So what this does is, whenever I stop the container, yes. So whenever this container will stop, we will see that this this container will be removed automatically. So I have just started. I have just started two containers with two different portals. So if I go to the browser, what will happen is, first local host colon 2000, we see this one, and on another local host colon 2001. Here you will see three note of exclamation marks. Here that is. So these two containers are running right now. These two containers are running. Now if I put docker ps, we see that with two images, two containers have been started and they are running. One is listening to 3001, another is listening to 3000. So now what will happen is that I will stop one of the containers. Say I will stop node count. Okay. Yes. Docker stop this one, node count. Okay. So by default, if I now list the containers, these containers should appear on the history. but here you can see that node cont is not there. That is because in the command I have issued to start it, to start the node, the command, when I used to, build the container, I have used the tag //rm --rm. So this one actually automatically removes the container from the memory, that is from the registry. So here on the next command, now if we run this one, say I remove this, what I have stopped right now, I have stopped node cont. Okay, so now what we will do is we will start node cont again. We will start node cont again without the RM flag. Without the RM flag. So now node cont is running and node cont one is not, node cont one I have put on ---- RM. Node cont, this container doesn't have the RM tag with it. So if I go and test docker ps, okay. So here we can see node cont and node cont one both are running. Again, I repeat, node cont one is with the RM flag. So now I will stop the node cont. This is without the RM flag. So if I stop, this is without the RM flag. Mind that. So I am stopping it. Now, if you see here, here you see the history is coming, node cont. Node cont one is also coming because it is not running. So I am stopping now node cont one, which has been started with RM flag. So it has stopped. Now if I come here and do a PS -A, only the first one without the RM flag is getting displayed. So the difference is, this one is run, there is no RM flag, and this one has an RM flag. So these things we must remember. So let us come back to our assignments. So this is the step 6 of the assignment, where the containers are removed automatically when they are stopped. Now, what is the Docker publishing? So if we want to deliver an app to our team, the main criteria for this is to make the code available. Okay, to make the code available across geographies. So what we can do is we create we create everything. Say we create Docker file, we create everything just we have created in this Visual Studio Code. We create all these files, we zip it and ship the zipped file, or we can just send out the image. So here we will deal with the image. Okay. Now I am just experimenting with this very basic node app. So I will, this is a very basic app to create Docker image publish. Okay. We will share the image through a Docker Hub post. So what we will do is we will first save the file. Then what we will do is after that we will build an image. So let me give it a tag, say node img pub. This is for publish. So we can see that node img pub, that image is built. We all know right now what are the commands to create a to name a image. Now we will we will run a container and see what the functionalities are. So first, let us build a container. We will run this on 3002 port, okay, and we will give the node container 2 and node img node container 2 with rm flag, and here this node img pub. We will run this as detached mode. So it is running. So when we go and see over here, say I'll just change the name, port number, that is 3002. So we can see that the changed image is appearing. This is the very basic app to create Docker image publish. Okay. Now after that, when we created this image, we have the image name over here. Now we want our team to access it. So to do that, we will have to create an account. Account where? Account in the Docker Hub. So this is dockerhub.com. So here I have created an account. To create an account, what you need to have is an email ID. Just you have to have an email ID and password, and your account is created. Okay. So this is a free account. I will not go into nitty-gritties of creating the accounts and all. So that would make the video longer. It is just creating the just like creating a new email address, but very simpler than that. And we always, encourage you to use the free one first, and then you use the uh, paid one if you require. So here, what we need to first create is we need to create a repository. Okay. To create an image, we need to create a repository. If you see, I have already 2 repositories over here. That was for my older codes. Here, I want to create a repository. So here first, my account name, and I gave is my pub, or say node image pub. So that was my node image pub. So what I will do is I will give it a name and I will create it. Okay. So now the next thing is that if you see there is nothing. So we have to upload this image, the image we have created into this I would rather say into this repository. Okay, into this repository. So to upload that image, I have to match this name. This is my account name slash the node image pub name. So I will have to create the repository, create the image name in this format. So what we have done is in the Visual Studio Code, what we have done this, we have done, or we have created just node img pub. So here what we have to do is just to say copy this name from this repository, that is this command. Just copy this, and uh, here we will put control key. So this will be my image, and at the end I can give a version name. Say I say 14 because this is on node 14, the code is on node 14. So I gave it this name. First thing is that when we build the image, we give the repository name which was there on the Docker Hub. Now we build it like this. And now here, this image is getting built on my local machine, that is on my laptop right now. Next, what I need to do is I need to log into my Docker account, Docker Hub account. So just one thing, Docker login. So I think it is using my existing credentials. So I will just log out and try login. This is the login. And this is the password. It will verify. It is saying login succeeded. Now, what I need to do is I need to issue this command, that is docker push, and then the image name which I gave over here. So it is now trying to push to Docker Hub. It will take a little bit of time. So all the links have been opened. So it is saying that it has pushed. Let us see. It has pushed or not. I'm just refreshing the page. So here, then that tag I have pushed, it is already here. Now, what I would do is I would just go to the Docker console. I am seeing that these containers are running. I will just stop them, stop and remove them actually directly. Remove. This one is running, so I'll stop it. Okay. So finally it has stopped. Now there are no containers over here. What I will do is go ahead and delete all the images. So absolutely there are no images left in the system. We have cleaned it up entirely. So no containers, no images, nothing. So now if I go over there, I have to log out. So I have logged out. There are no images. There are no processes running as we have seen. Now what I will do is I will just issue the command. Yes, just issue this command. Docker build -t from this web address. It will execute. I will show it later. Just first for this, if I just run docker ps, there is nothing. Docker ps -a, there is nothing. Docker images, there is nothing. So now what I will do is first I will try to pull the image, that is download the image on my local disk. So this is called Docker pull. What you have to do is account name slash the image name. What is wrong? I haven't given the tag. Okay. So now we can see that we have been able to download this image. Okay. So if I go and uh, run this command, yeah, if I go and run this one, say note count one, and here it was the account name that we will have to give. So I will put here control V. So this is the image name. What was the name? This is quite long, but still. Yes, it is running. So we have to give the full name with the tag. So it is running. So we have the image name, we have the Docker right now. If we go to the desktop, here we can see the image on disk. It is saying images on disk, and it is saying containers. This node conf one is running. So if we go to the browser now, the port was 3002. So we go to the browser now. Here, local host 3002. You can see it is running. My point is not this one. By default, I don't want to drop an image directly to my disk and run it. That defeats the very good purpose. Like I am running an image of around 1 GB on this system. So that is not what I wanted to say. So now we have one container that is running. Now let us stop this. So we have ran it with RM. So this one will delete automatically. So this one is deleted, and you see the container is not there. Only the image is there. So what I would like is to delete this because this is consuming around 1 GB of my disk. So I have deleted it. Now what I will do is I will run this from this. This was the image. This was the image. Now if I see Docker images, there are no images. Okay, now I will run this directly from the Docker Hub. That was my purpose of showing this. I will give node conf from hub. I will give the container name as this. I will assign the port 3000 and do it. So I haven't downloaded the image, but it downloaded the image itself and ran this content. So that was it for today. Thank you. Thank you so much. Good night.